Hello and welcome back to the series on gradients, which is now turning into a series about differentiation. So in the last episode I introduced the idea of differentiation of simple functions, i.e. just where there is one variable x and that x has been acted on by one function such as sine x or cosine x or x to the power n. In today's episode we're going to ask the question, what happens if you have a summation of these simple functions, i.e. something like this, where y is equal to 2x to the minus 2, so that's one simple function, added to sine x, which is another simple function, plus 12, which is a constant. So when we address a summation of functions, what we do is we treat each one individually and add them all together. So dy by dx, what we do is just work our way along. So the first function is 2, so that's a constant, so that's going to stay where it is. We're going to take this x to the minus 2, so this follows bring the power down in front and then reduce the power by 1. So we're going to have 2, we're going to bring this minus 2 down, so that's going to go to minus 2. X stays as it is, and then we reduce the power by 1, so minus 2 minus 1 is minus 3. Next up, we're going to add this to the next function, so sine x, so the differential of sine x is cosine x. And finally we have the 12. And in the case of differentiating a constant, which is the equivalent of doing x to the power 0, so this is 12x to the power 0, we could write it as. This is basically a flat line, so it has no gradient, so it just goes to 0. So dy by dx is equal to minus 2 times 2 is minus 4. X to the minus 3 is the same as writing this to x over x cubed plus this cosine x. So that's how you do summations of this. In the next episode we'll look at what happens if the functions are multiplied by each other and using the product rule. So as usual, please subscribe, thank you for watching, and I'll see you in another video soon.